linear equation. Consider the family of linear equations of the form shown below, where z is a rational number. So in other words, we don't have a square root, but we could have a fraction. Solve the equation for when z is equal to 1. Right? So I'm going to rewrite this. Well, I'm going to write z is equal to 1x. All right. So 2/3 times 3x. These cancel out. So we get 2x, because 2 times x is 2x. 2/3 times 2 is 4/3 is equal to x. Okay. Let's subtract 2x from both sides. Negative x times -1. So x is equal to negative 4/3. Find a value of z such that the equation has no solution. Alright, so I'm going to rewrite the equation. So we have 2x plus 4/3 is equal to z times x. Okay, sorry for the pause there. Anu's listening to something and got something special for you to listen to. If you hear this and you can sing this or write it down, I will give you a homework pass. First person in every class to either sing it or have it written down will get that homework pass. All right, here it is.
His ankles, he's just singing Valentine. His eyes are as green as a fresh pickled toad. His hair is as dark as a blackboard. I wish he were mine. He's really divine. The hero who conquered the Dark Lord.
How can you possibly not love that? All right, so find the value. Back to the problem. Find the value of z such that the equation has no solution. All right, so for this to have no solution, we have to have a parallel line. And clearly, the slope of this line is 2. Therefore, to get a parallel line, we'll have to have a slope of 2. So if we have z is equal to 2, we will have no solution, because we'll have a pair of parallel lines. So the other obvious question is, why is it that we cannot have an infinite number of solutions? And for an infinite number of solutions, you have to have the same line, right? The same slope, which we have here, and the same y-intercept. But we don't have anything added to x in this case. So therefore, we cannot have identical lines, which is why we can never have an infinitely many solutions. And that's really just about it. Last one. Oh, we had a problem just like this. Instead of a baton, we had a flute. All right, Olivia is shipping a baton and a few other things to a friend as a gift. The box measures 8 by 9 by 1 foot. So that 1 foot I'm going to change to 12 because we need to have the same dimensions everywhere. She places the baton in the box as shown below. What is the length in inches of the baton that she placed in the box? In other words, it wants to know that long diagonal. And for us to find this long diagonal, we first must find this diagonal here. Because this triangle, I'm going to draw it from a bird's eye view, is a right triangle, because the box has right angles, where this is 12 and this is 3. And using the Pythagorean theorem, or sorry, I jumped ahead. That's 9. This is a 3, 4, 5 right triangle with a scale factor of 3. So therefore, 5 times 3 is 15. Now I could have also said a squared plus b squared is equal to c squared. So 9 squared plus 12 squared is equal to c squared. So we get 81 plus 144 is equal to c squared, so we get 225, sorry, is equal to c squared, square root, we get 15 is equal to c. But if knowing the if you can recognize the 3, 4, 5 triangle, you're going to be better off. So we know that this is 15. Now in this case, we have another right triangle, where we have now this is another famous Pythagorean triple. Let's see, ever popular 8, 15, 17 right triangle, but we can do 8 squared plus 15 squared is equal to c squared. 64 plus 225 is equal to c squared. So adding it together, I get 289 c squared, square root, and so I get c is equal to 17. What is the length in inches of the baton that she placed in the box? Okay, we just said. Olivia thinks that the relationship between the longest diagonal in any rectangular prism and the dimensions of the length, width, and height of a rectangular dimension can be modeled by the diagram and the equation. Okay. Without substituting in numbers or for variables, show or explain why the equation is incorrect. All right. So the first thing we did is we said L squared plus W squared is equal to H squared. And therefore, the square root of L squared plus W squared is equal to H. So then, oh, crap. Oh, this is really simple. We needed this dimension, didn't we? Because that was our intermediate, that's our intermediate step, right? So let's call this Q. So that's equal to Q. So then we could go on and say that D squared is equal to H squared plus the square root of L squared plus W squared squared. So that would give us H squared plus L squared plus W squared is equal to D squared. So we end up with D is equal to the square root of H squared plus L squared plus W squared. Huh. I wonder if that works. Let's find out. So let's plug in the numbers. I'm really curious if it works. So we had 8, 12, and what was the other 9? Alright. So 64, because that's 8 squared, plus 144, which is L squared, plus 81, which is W squared. So let's add them together. Let's see what we get. 64 plus 144 plus 81. Check that out. And I get 17. So this is definitively the equation that will get us the final answer quickly. Alright, I hope you enjoyed this video and the song. Let's see who gets the homework pass.